All right, so our group worked with John Deere to create a Python library for a robot arm. I'm working alongside with Jack Law, Jared Smith, Leo Wilkojek, and Jeff Hansen, and I'm Sam Penny. The company overview. John Deere is a pretty big name in agriculture as well as construction, forestry, machinery, but mainly we're working with electronic solutions in order to develop this arm.
So the problem we had was that John Deere wanted a robotic arm for functional testing. This required a forward and inverse kinematic library to solve for those positions, and that required methods to get position, move to a new position, and set and get the rates of movement. Our solution for that problem was a command and control library which allowed our computer to control the robot arm directly, as well as providing virtualization to better understand and test the arm before using the physical arm. We also needed support for multiple solvers, as different solvers do a couple different things better than others. And lastly, it had to be well documented and easy to read so that John Deere engineers could develop it further in the future.
So some of the challenges and risks that we had, the project scope was relatively narrow, so it took us some time to figure out the best way to approach the problem. And furthermore, the implementation of the inverse kinematics and the limitations with the robot arm posed additional challenges. And of course, COVID and distance learning just kind of piled onto that. But we overcame that pretty well, breaking down a post mortem of what we did. So, in terms of effort, about 20% was on the requirements, about 30% was in the research and designing of our project, about 25% went to the actual development or writing code, and about 15% went to testing, and finally about 10% went to the redesign. And in terms of metrics, there were just shy of 2,000 lines of code, about 16 separate code files, and we worked on average 60 man hours per week.
So we ended up having three different solvers in our solution. The first one is PyKDL. It's developed by Oricos, the people who make the robot operating system. It only works on Linux, but is quite robust. Our second solver is IKPy. This works on Windows primarily, and it's our main solver. And then our third one is RTB, our most elaborate solver. And that one is also much like IKPy, a Windows solution. And for virtualization, we have our virtual arm for plotting, and we use the URDF, Universal Robot Definition File format, to give John Deere the ability to define their own robots and use in several different kinds of solutions.
For our future steps that John Deere can go with this, they have the ability to explore that robot operating system, specifically through the use of Oricos KDL, but that can be expanded to pretty much accept any kinematic solver that is on the market. To possibly integrate a stereo camera for some localization problems, and to simulate with higher accuracy using Gazebo over the Matplotlib visualization. We'll now give a quick demonstration. If I can have Leo pull up the uh, screen share here.
Yep,
Um,
you're good.
our demonstration will be just walking through our demonstration file that we have handed over to John Deere. The first part of this is just instantiating a new arm, and you can see it setting itself into its default position. This way, the arm knows exactly where it's at as it starts in the same place every time you construct a new arm object. In order to input a command, you have to wait for the previous one to return. Here we can see that we can grab the current position in coordinate space and also look at its angles and degrees that it's in. We can move to a different position using the simple move to command. We can slow it down a little bit, and we can move to a new position, this time also incorporating roll, pitch, and yaw into our uh, input coordinates. So hopefully we'll be able to hit those angles that we're aiming for here. that we get a new XYZ position, and here the roll, pitch, and yaw are output in radians. That will be all for our demonstration. I hope you guys enjoyed a little bit about what our group did with John Deere this semester.